Yes, we do have it.
Maybe you could share it.
Okay, let me see. Does everyone have the
Uh,
presentation?
Very strange
Um,
setting.
Yeah, I tried sharing too, and it says post disable participant screen
Yeah, I
sharing.
I don't know how to go in and,
So was it on the, Carol, was it attached to the invitation to the meeting?
no, I sent it after that. I sent it just by itself on 5/22 at 11 o'clock in the morning. I don't know how to do
I hope,
this
I mean,
stuff.
I don't know if everyone doesn't have it. I don't know what.
NASA.
Oh, shit, okay. 5/22.
Carol, do you have it? Are you able to share your screen?
You should be able to, Carol, at least.
Post.
I don't know. I don't know how to, when I set up the meeting, I set it up so that everyone could share. So
So
I don't know.
if you can open up that presentation that he had on your desktop,
Yep,
and then you can share it.
I can share it. All right, hold on.
Yeah,
You have to open it first. And then pick the screen where it's
Let me see.
located.
Uh, Okay. So I have it up.
Okay, now you share your screen. And you'll see a series of probably windows, and you pick the one where it's located.
So PowerPoint.
Sure.
Let's see.
Should
Screen.
be it.
I'm not sure if it's a PowerPoint file
Yep.
that I sent you or.
There we go. Is that what you need?
No. Oh,
Yeah.
okay.
There we go.
wow.
Maybe we can do a, let's see, full screen view. How do we do that? Maybe you can zoom out a little bit. Can you click the little minus symbol on the top of your? Next to the plus.
Yeah,
Just
I can't move the screen, so I can't.
That's okay. It can, there's a little minus button on the toolbar, like
Yeah, I can't see the, oh, wait a minute, here we go. I just have to move this. Nope.
there's a different minus. It's next to the thing that says read aloud.
I'm sorry.
Yeah.
I don't know. I'm sorry. Where else do you need me to go?
Oh, there's just a little symbol so you can see the full slide. If you just click on the minus symbol that's next to read aloud. Do you see the, just to the right of there? Oh,
In the middle.
kind of in the middle.
This one
Yeah.
here?
Yeah,
No,
you
next
just
to it,
click the
right next to it.
Click the minus button. Yeah, right there.
Okay.
Click it a couple times, maybe.
How's that?
All right, that's good.
Okay.
All right, do you mind just scrolling down? So I'm just here to give you an update on the vulnerability assessment and resiliency strategies for the wastewater treatment and pump station facilities. Thank you. since our previous meeting, we had a survey team that went out and took some spot elevations just to confirm that we were using the right elevations for like the first floor elevation of the pump station and the treatment plant and some of the other buildings and electrical facilities. And what we found generally was that there was, for the pump station and treatment facility blower building, there was about a half a foot. The elevations were half a foot higher than we had been thinking based on using a USGS datum conversion tool. So that means that the risk is less than we presented last time. It's still not a pretty picture, but it's less bad, which is good. And also, in addition to kind of updating the vulnerability assessment for each of the facilities, we have some updated graphics from some mapping, some presentation material we developed for the public presentation. And finally, in terms of recommendations, we kind of broke out our recommendations into kind of some phases. So some near term and some longer term. So you can keep scrolling down. This is material I presented last time. As you know, we're using the Massachusetts Coast Flood Risk Model. These
Sure.
are the sea level rise projections. We're using the high projections. I created this map previously. I had just shown like a map showing the extent of flooding, and it was, kind of not very easy to discern what was happening there. So I just put the sewer system infrastructure assets that we have in GIS, on here for you to kind of see how that overlays. And so,
Can we go back to the last screen too? if you had a chance?
am I scrolling up, Carol? Thank you.
So you're using the blue line, which is the high projections.
That's
You
correct.
have
Yeah.
the intermediate, intermediate high, intermediate. Is there other projections too? Is there like a low as well?
So these are from the state's projections. The state
Right.
didn't publish a low.
Okay.
I think probably the next line that you would see might be a like a historical trend, like the long-term historic trend.
Yep.
Which of course is lower, but because sea level rises is or is expected to accelerate, just having one kind of the linear flat line into the future kind of we understand underestimates the risk, but that would be kind of, if
Right.
everything continues the way it has.
I was just noticing that the monthly averages are a little bit below the intermediate, and that's why I was kind of curious if there were another projections.
Yeah, I understand. Yeah, I mean, it's so previously the lines the reason it says update is because my colleague kind of added some previously we just showed the 2020 projections, so you were already like seeing that, like, well, in 2020 we're below the intermediate projections. But by tracing back to the start date of these projections, which was 2000, you can see that for a period like in the 2010s and before that, we thought we were tracking the high curve or even the extreme curve in some cases.
Yeah.
And then over the past 10 years or so, we've been on the lower side of that. Now it's normal that there are phases of tide cycles that happen, astronomical tide cycles, just based on the rotation, and position of the moon and the earth and sun. And it goes through phases. So there's some articles you may have seen in the media, or maybe not, because you're not a climate nerd like me, but there's some reports in the media that say, well, around 2030, we're going to be back on the upside of some of these cycles. And so, while we're on the low side of the cycles right now, that, come 2030, we're going to be on the upside of them again. So it's really hard to anticipate exactly where we're going to go. What we know based on the probabilistic analysis that informs these is that we are very unlikely, like 99.5%, to exceed the values shown on this graphic by the dates shown on this graphic. So we are very likely to exceed 1.3 feet by 2030. We are very likely to exceed 2.5 feet by 2050, et cetera. And if sea level rise follows a more intermediate curve, which is what a lot of the federal projections are based on like when NASA or NOAA, these agencies, put out projections, they're typically, pointing to the intermediate projections as kind of the middle of the road projections. So the thing is that if ice sheets become unstable, as our I guess instability of ice sheets is incorporated into that high curve and more so into the extreme. But basically, like, if you follow the intermediate curve for planning purposes, there's a 50-50 chance that, with ice sheet melt that you're going to under design for the future, that you're going to under anticipate the risk. So ice melt is a big area of uncertainty, and the projections we're using captures that. And if sea level rise is not as bad as projected here, the results that we're showing in these maps and the elevations, et cetera, are still valid for a future time horizon. So it could be that it shifts out the time period where you need to act, or it extends the life of something that you've designed for a particular time horizon, another 20 to 30 years.
Yeah, that's what it looks like on this, that theoretically it could be 20 or 30 years later if you use the intermediate curve.
Yeah, and we don't have the flexibility, unfortunately, to change the modeling that we've done, but like communities have the flexibility to, change how they think about 2030. Maybe you're talking about 1.3 feet instead of a specific time horizon, and you call it 2030 to 2050. We had this in one community where there were some quite skeptical stakeholders, part of the steering committee, and they said, we'd rather talk about it as, a 2030 to 2050 time horizon. So, that's reasonable as well.
Okay, I mean, basically it's a pretty conservative
It
estimate.
is, yeah. By design, right? So that we don't have to, so that we haven't underestimated. Yeah. So these are the numbers that are baked into the MCFRM maps, the Massachusetts Coast Water Smell. So you can continue, Carol, if you don't mind.
Okay, one moment.
No problem.
I just have to. All right.
Okay, so yeah, so these maps are showing, I previously showed the extent of flooding. These probability maps show you basically the extent of these different probability of flooding zones. So you can see, obviously the resolution of the model you can kind of get a sense of by the size of like the band, like for example, the 1%, the pale green band right between that's, it's a pretty narrow band there. So, our resolution is quite high. And then I think we have an image of it in the vulnerability assessment memo that we shared with the town. But it's not as fine as LiDAR, like every foot or every 5 feet or something like that. It's a little bit less so. So at the treatment plant, we don't get great resolution from this map. We know that it's surrounded by, a very low lying area, and therefore it looks like it's at high risk. And that's why we did the more detailed analysis of critical elevations and compared them with, the water surface elevations associated with these different probability levels. But generally what you can see is that we have, potential for flooding in Jacobs Brook, basically probability of water crossing over these kind of flood pathways, these coastal flood pathways at, Summer Street around Black Horse Lane and around Elm Street and Border Street. In this time horizon, there's, a 2% risk. That means, 50-year storm could overtop those coastline elevations and flood Jacobs Meadow. If we go to the next one, yeah, thank you. We can see that the probability of that kind of extent flooding raises to 20%. So that's a 1 in 5 year return period. And if we go to the next one, this is where there's a real shift change in 2050, where you can see now it's, 50-year, a 50, this is, the legend is incorrect here. The blue color that's filling most of the center area here is a 50% probability. So that's a every other year flood risk, and it's, you know, the area crosses South Main Street. I remember in our last meeting, sorry, yeah, I did replace this graphic, and I apologize if I had been able to share my screen. I could have shown you the replaced graphic, but I'll circulate it after this meeting. But I think the important thing to note is just that I think in our last meeting, someone had made the comment that basically, you know, in 2050, you know, so much of the service area is underwater so frequently. So, you know, kind of throw your hands up in the air, like, you know, what are we going to do about it? What are we going to do about it? I wanted to just highlight a couple of things. One is that, you know, there is a pretty large part of the you know, collection system service area that's not in this high risk area too. So, you know, even if other measures aren't taken to mitigate the risks that are indicated here, you know, with all this flooding in Jacobs Meadow and James Brook watershed, you know, there's probably still a case to continue the life of the treatment plant, treatment facility and pump station, et cetera. And it's just a matter of adapting it to, you know, the future risk that it might be exposed to. That's easy to be said and more difficult to do. I also wanted to point out that as part of this project, we're modeling and developing conceptual strategies to mitigate these risks that are shown here. So we're coming up with strategies to mitigate the 2050, you know, 1% flood risk, primarily by, you know, raising low-lying roads along the outskirts of the flood zones. So like a Summer Street, there's a private road shown near Black Horse Lane. We're also looking at an Elm Street at the waterfront, and we're also looking at even, you know, modifying the bridge and some of the low-lying areas to either side of it at the Gulf. So we're modeling those two, and we're also modeling the breakwater to see, you know, if the breakwater were adapted, would it help to mitigate some of the wave heights that would require you if you were trying to protect, let's say, at you know, the Veterans Park, you know, seawall at the waterfront on Elm Street. So you could, you know, design that to be at a lower elevation instead of a, you know, 6 foot high, 7 foot high wall in front of your face, right? So we're modeling all those elements, and when we have a public meeting, I think June 12th, that'll be the town-wide focus. We'll have hopefully some results from that, as well as depictions of the engineering strategies and kind of order of magnitude costs. So, you know, in that scenario, you know, the infrastructural solution for the treatment plants facilities risks in 2050 are a regional kind of scale, you know, led by the town. But, you know, as a fallback, it's good to have your own set of strategies for your infrastructure in the event that those plans don't come to fruition. All right, so moving on, there's one more map, I think, here for 2070. Yeah, this is what it's supposed to look like for the probability of flooding. You can see in 2070, obviously things are significantly worse. This is the annual, you know, flood extent shown here. I guess the last point I wanted to make about these maps, and I probably made it during our previous meeting, is that the risks that are shown west of kind of North Main or South Main Street are probably underestimated in all these graphics, because there are underground connections, culverts, et cetera, that water could backflow. You know, once Jacobs Meadow is flooded, water could backflow to these other areas. And we've collected a ton of information about those hydraulic structures, and thanks to Daniel for sharing information that they collected as part of the master plan, flood control master plan. We're working on kind of getting that model operational so that we can better categorize those types of risks, as well as combined risks from heavy rainfall and future sea level.
One thing that you can look at here too is the Atlantic Ave area, Hobart, Lothrop. That's all underwater.
Yeah.
And a good portion of the areas around Little Harbor are also underwater. So you have a lot of infrastructure up there that's going to be underwater as well.
Yeah, it's true. Our study is kind of limited to the James Brook watershed, but there's good case for this same data, which the town either has or will be giving to them, to look at those other types of risks as well. And we're a little bit limited by kind of what kind of GIS information is already available about the location of that infrastructure.
Can I ask a question? Are you doing a similar study in Hull? And the reason I'm asking is we utilize Hull in their pump station
Yeah, I'm familiar.
more than once, and wondering, what kind of impact this has on them.
Yeah, no, I've been working with the town of Hull since like 2014 on planning for sea level rise, and the Hull faces some pretty existential long-term risks in 2070. Like, much of everything except for the hills kind of looks like this blue shown here.
Mhm.
So it is really they're probably, I think they're the most vulnerable community in Massachusetts as a whole community. The treatment plant itself has been the subject of a lot of design, planning, and fundraising, and I believe they either are pursuing or are working through obtaining a FEMA grant to construct some improvements that were already designed, and I think maybe somewhat through the permitting process. So they are, building a flood protection system around their treatment facility. Berms, flood walls, gates, etc., to protect it from long-term flood risks. So even if it's the last thing standing aside from properties up on the hill, hopefully that facility can continue to provide Cohasset with regional sewer services as well for parts of the community.
Are those types of mitigation something that we should be looking at?
For this facility?
Yeah.
That is part of the long-term set of options that we have on the table. I think we talked about it last time, and Daniel had some comments about some of the existing walls around this facility. I think because of the footprint and the surrounding environment here, you need something with a smaller footprint than they have a little bit more space there, so they're able to build berms and things like that. Here, you're very limited because of the salt marsh surrounding the facility, and so you probably want to go with something like a sheet pile wall, which you already have to kind of retain the material around the treatment plant, but it could be adapted or replaced in the future with a wall that's designed for flood protection, and that would have to go down to cut seepage off as well, because I know with tanks and things like that, Daniel was pointing out buoyancy as a potential risk from groundwater. So so I think in the long run, yes. In the short run, I think it's worth the community having the conversation and evaluating the regional flood protection strategies as a first, because the benefits of implementing those solutions will be a lot higher than just the treatment plant, right? In those cases, if you're able to mitigate a bunch of this flood risk at a regional scale, well, you've protected businesses, your customers, residences, your customers, your sewer manholes, and all the places where you could have inflow, the road network, public safety access, etc. So I would say it's as we'll get into a little bit later, it's rational for you to take some near-term steps to reduce some of your nearer term risks, and then have in your mind that there may come a day, if these other actions fail to proceed, where you need to start considering more significant measures.
As part of your study, to give us a list of these measures.
Yeah, and this actually should be covered essentially in this presentation. They're still
Okay.
listed as options for you so that you
Yeah.
can kind of choose a scale of action. So I'll just keep going here. One of the first areas, the vulnerable sewer manholes. If you don't mind scrolling down, Carol, when you have a sec.
One more question while we're
Oh, sure.
in the interim, on the whole improvements that are being done or contemplated at this point in time,
Yes.
what is that supposed to protect them up to? What year? Just curious.
That's a good question. Let me ask my colleague while I'm waiting here. I'll ask, and then if I get an answer, I will let you know. I previously highlighted that, there are a lot of sewer manholes that are potential sources of inflow to the treatment plant, which is not good for the processes that are, used there, with the introduction of salt water, et cetera. There were, I guess our main concern, our biggest concern is the trunk line manholes that are right in the center in Jacobs Meadow, because that's kind of, if water is flowing in there, that means that probably sewage upstream in the network is backing up at that point, and you're getting just a really high concentration of seawater because it's at the very end of the pipes before they get to the pumping station. But there are these low-lying manholes along the coast, along Margin Street, along Border Street, Black Horse Lane, that are lower and therefore have a higher probability of flooding in the near term. Brian was explaining to me that when he did the repaving on Border Street, that they upgraded those to watertight manholes, which is positive. And so compared to last time, I've taken those ones out of the numbers that are shown here. So there's a chunk of risks in the near term that have been mitigated just through good stewardship of the
Yep.
infrastructure.
One thing I should mention is the ones that go through the Jacobs Meadow area, the ones you have in orange. Those for the most part were original watertight manholes.
Yeah.
They may need some upgrading, but to some degree, they should be fairly tight.
Yeah, that's what we gathered from talking to Brian and also looking at the old plans. Yeah, they were originally watertight. I'm sure with gaskets, et cetera, that they're no longer so, but maybe are still generally tight. They also may not be designed to withstand the loading of flood levels that could be put on top above them. So that was something that Brian was concerned about as well.
Yeah, it's very true. The ones
So
we
look at that.
installed over on Border Street had a very high rating, so.
Dan, when that diversion was done for the condominiums on Elm Street down below, did they put watertight manholes back in on the manholes that they installed?
I don't believe so. I don't think we were starting to use the Pamtites, which have the high 14 PSI rating. So I believe those were not upgraded to Pamtites. The only ones we upgraded so far to Pamtites are the ones on Border Street during the paving project.
Okay. I know about a month ago or so, I sent Carol some pictures of a backyard of about I think it might be 110 or 120 Elm Street or something. And where the septic came right out of the covers, and that's not too good.
No,
Second thing is,
Sounds like a blockage.
I don't know what it was, but then the other question is around where the monuments are. That water at one point in time was up 2 or 3 feet, and I wondered if the new buildings that are being built took any caution of how they gotta take their underground parking and seal that up so that the water isn't going to go there and this will be in the next 5 to 10 years or something. So it's just a little scary if it is same elevation that it was when you started, but we've had water up 1, 2, 3 feet in those areas.
I've looked at the landscape plans. You're talking about the hotels, what's it called? The former hotel site on the waterfront. Yeah.
Also across
I
the
think their
street too.
first floor elevation is proposed elevation was at 12, NAVD 88. So, that's like
with isn't the
there's
landscaping going to be higher than the entrance to the parking garage, for instance, which is at the ground level it is today.
Yeah, I didn't even know that there was a parking garage under there, but
That's across the street, actually, at
across
87.
the street.
There's a garage under the building, under the big building, big building too.
Okay.
Okay,
So, yeah,
Oh.
some landscaping has been raised, if I had been a consultant to the town as you were contemplating that plan, I would have given you some other suggestions as part of that, but that no community is short on if only, things we should have done. So we gotta, move forward, unfortunately, but yeah, I mean, I think your concerns are totally valid about, underground parking and just sewer system design. Potentially as part of future projects, you may want to consider, zoning, updates to bylaws, et cetera, that can help to put requirements in place that development projects be designed for future risk.
I think
the
that
extent feasible.
generally speaking, on almost all underground parking, they are handling the fact that no utilities can be, the utilities, everything has to be to the top of the ceilings. And
Yeah.
So it's,
There's usually some kind of, some pump somewhere, that hopefully has backflow prevention on it, so it doesn't take in water instead of pushing it out, but assuming it's a force main, then hopefully that doesn't happen. All right, well, let's move on. So another thing we had pointed out previously was just the vulnerability of site access. And this is showing kind of the road from Elm Street, which is fairly high, sort of once you hit Elm Street here and go west, you're on relatively high ground. This area is not as exposed to flooding, so that's good. It means that there's a potential for access to continue in the future, even if you're facing, frequent flood risks. But the ground elevation gets pretty low, down to around 8 feet or so. I guess one of the challenges with correcting this problem is, again, the adjacency of wetlands. If you were trying to raise this road, you have to use more expensive construction methodologies, like using, sheet pile kind of retaining walls to be able to, add fill and raise the height of this. You also need to consider kind of the small parking area in front of the pump station. So also need to add fill up against that existing structure. And my sense is that it should probably be able to take that, given the rest of it's underground, but that is not, I'm not a structural engineer, so that's, for someone else to evaluate. We did come up with a relative cost to do this. Another challenge is just that you can't raise this road so high that it's higher than, say, the treatment plant first floor. So, we estimate that probably the highest you could raise this road is like 9.5, which doesn't get you, it gets you some reduced risk in like in any time horizon, really, right? In terms of the annual likelihood of flooding, if the rest of the regional solutions aren't implemented. But it doesn't get, it can't resolve, it can't give you like 100-year flood protection in 2050 just by raising this road. Like you're never going to have that level of access resilience here, with the road where it's at right now, and with the facilities where they're at. But you can do some things in the near term that buy down that risk, fairly substantially for present and 2030 risks. If we could keep going here, I'm going to kind of breeze through these just to say that they're updated, that there was a ½ foot. So we were previously showing the finished floor of the pump station at 10.5. We're now showing it at 11. So if we keep going with the scroll, and the treatment plant, we had previously been showing the effluent tank rim as 10.5, and now it's at 11 as well. So you can see here, very low probability of flooding, 0.1% chance, that's a 1,000-year, flood level in 2030 with that 1.3 feet of sea level rise. If we continue going, similar, the same level of risk for the effluent pumping station being underwater. Continue, please. As we move into 2050, that increases to about a 50-year, 2% annual chance of flooding. in both cases. You may continue, please. And you can continue on to the next one. And by 2070, excuse me, did I miss a 2050? No, okay. This 2050, okay, 2050, we have 2%, right? So that's a relative, like, honestly, I work in a lot of communities, you know, to have a piece of, to have infrastructure this critical, you know, with that low of a annual probability of flooding in 2050 is like, you know, go celebrate, you know, it's, these numbers are very high. The projections, the sea level rise projections are very high. In addition, we've got, you know, bigger storms in 2050 and 2070. So it's really positive. As we move on to 20, you still may want, you know, more protection, but and your access and things like that could be impacted more frequently. But as we move on to 2070, the risk becomes kind of, you know, fairly untenable, right? With 50% annual chance. So every other year on average, getting water levels this high.
And the other thing is just to mention, this is the high projection, although you think you're going to be there.
Yep.
By this time anyways,
Right. This is the high
but-
projection.
who knows? Hopefully,
Yeah. Who knows?
hopefully it's not as bad.
Hopefully it's not as bad. I agree. All right, so we'll just keep going, continue on. All right, so to this table, yeah, okay. So this was the kind of summary table I presented last time to try to help figure out, you know, when are things vulnerable in different time horizons at different probability levels. I updated this, so if we scroll down to the next slide, based on the new information. So one thing that changed is well, I added a 10% chance of a flood in present day, just to capture that kind of inflow. There are vulnerabilities in terms of inflow of those manholes at that level. Another thing that changes, the emergency generator now is sort of green until you get to the 2051% chance. So with the survey elevation information we got back, that moved down in our list of vulnerabilities. And also that the transformer and switch at the pumping station, that is basically the site electrical distribution, is more assuredly vulnerable in the near term than we previously had discerned. So again, the positive story. So the orange here for like the blower control building, the treatment facility, et cetera, you know, that means that in those cases, water is inside the buildings, it's above the first floor elevations, but it's not high enough to cross those critical thresholds at which, you know, processes would be impacted, critical equipment would be impacted. So still a problem, still something you don't want to have. You don't want a bunch of salt water, you know, inside your facility, but, you know, something that can be recovered from.
I think the big, one of the big emphasis here though is the electrical distribution and power
Absolutely.
supply. That's because that's significantly compromised potentially, and that doesn't only have to do with you, but it also has to do with the power supplier.
Good point, yeah. So if we scroll to the next set of slides here, so I've updated these resiliency options. This is something I presented last time, just to say that there's the state has published climate resilient design standards that utilize the same MCFRM data, depending on the criticality of the infrastructure, which you have to kind of go through a questionnaire and answer a bunch of questions. It's somewhat sensitive to the number of people impacted or the dollars in damages that would occur in terms of whether you're a medium or a high criticality. You may think you're high, even if the tool says you're medium. So, you know, for utilities, you can see here, we've got something like a 1% or a 0.5% chance is what we should potentially be designing for according to these standards. And I'll also add that sometimes these standards are not achievable just due to feasibility constraints or cost constraints and or even regulatory constraints, permitting, et cetera. So they are guidance, they are not requirements. We may scroll again. I wanted to just add the water surface elevations in case, you know, beyond my involvement in your resiliency work at the treatment facility and the pump stations, if you're making upgrades, et cetera, that you have these numbers, readily available to do with them as you may. But what we've done is sort of develop some concepts and cost based on initial level of adaptation to the 2050 1% water surface elevation, which, as if you recall, our threshold where we were vulnerable was at that 2% level. So 50-year versus 100-year, which is it's a modest jump in terms of elevation, like probably less than a foot, but maybe something still worth investing in if you're not protected to that level by some regional flood mitigation strategy. If we may continue to the next. So this is the meat of, I guess, what I wanted to talk about. We came up with some different options for kind of a 2030 target time horizon in terms of things that the town can do. And these are kind of scaled up in terms of what the level of ambition and cost. So one item is to replace, manholes with watertight manholes. I was talking to Brian, and he was saying that the town is going to be doing repaving on Margin Street, and that as part of that project, similar to how Border Street was, the manholes there were upgraded at that time. That, of course, doing those two things together makes such good sense, right? You don't want to rip up the road you just repaved. So, and when you're already disturbing the soil is as good a time as any to go ahead and do that. So looking at, these are order of magnitude costs for replacing the 17 manholes in Jacobs Meadow on the trunk lines and the 6 on Margin Street. Those would be basically protecting all the manholes that were vulnerable in this 2030 10% level. Raising the access road to 9 feet. This is where some big cost items come in. And there's some uncertainty here, but significant amount of money to do so. You could try to go to 9.5 at a substantially greater cost, just because once you start getting above that level, you would need to do more sheet pile, basically around the back of the pump station building. And then raising the transformer and switch, that equipment pad that's there just being too low, and redesigning that so that it's higher up. So we are currently the State Office of Coastal Zone Management, which is funding this study, at least 75% of the total project cost, with the town providing in-kind and other resources for the 25%. They will be issuing their call for applications. Gosh, I'm surprised they haven't done it already. They usually have by this time already. So it could be any day now. And we talked to them. We had a meeting with the program staff there to talk about potential ideas here, including some of those regional strategies, trying to advance some of those in design, and also sort of either separately or together, something focused on the wastewater infrastructure. We talked about replacing manholes. We talked about, electrical equipment. They funded raising electrical equipment in the past in other communities through their grants. And so I wanted to put here these options with, get some feedback. And I was expecting Brian to be here. I'm not sure if he is or not, but I could always relay back to him, or one of you could, where we landed on this. But curious to know if there's appetite for pursuing a grant to help buy down the cost of some of these improvements. Going big would be addressing the access road, would probably, the way these grants are structured is you can go for a 1-year grant, which is really actually only about an 8-month grant at maximum, 6 to 8 months, just due to how the fiscal years and contracting timelines work out. That's probably not enough time to design and bid and construct the manhole improvements, but there is another option where you can do a 2-year grant, which ends up being, say, 18 to 20 months, where that would be feasible, where you could potentially check off the inflow and the transformer. not sure whether you could get through design and permitting of the access road in that period, just because of the sensitive resource areas around it. So I separated out, one option with the road, one option without the road. I think Brian was interested in pursuing, at least some scale of this scope for a grant, hopefully for a 2-year grant to include construction. So it's not just, services, but actual impact on the ground. Thoughts on that? Reactions?
Wow.
Other things you'd rather spend your money on? You mind scrolling back up? I'm sorry, Carol. Thank you.
A lot to do.
I would think it.
These include like, contingencies and markups and things like that. So it could end up being less, but who knows?
Are you gonna be looking at the cost of, pardon me, putting some sort of, whether it be like a hurricane barrier or that kind of thing at the breakwater instead of this?
We are looking at for that 2050 target time horizon, trying to see if we're evaluating different strategies to protect to the 2050 1% flood that would protect the larger area, including the treatment facility and pump station. So that would be things like replacing the seawall along in front of the hotel, the former hotel, and doing some road raising. At other places, putting in walls or raising roads, even as wild as replacing the bridge over the Gulf with a tidal control structure and a different bridge. So we are not evaluating a storm surge barrier at the breakwater. We have heard in multiple projects from the agencies that fund this work and that work with us on the permitting side that those solutions are not currently feasible in Massachusetts, that those the level of scrutiny and science that you'd need to present to be able to advance those types of strategies in Massachusetts, given our regulatory environment, is just not doable. They're looking at them in Florida, they're trying to do them, they're doing them in Texas, spending billions of dollars. The Army Corps is looking at Boston, but they're super, super expensive. The cost benefit analysis on doing something like that would be hard to justify.
I think option 2 is probably going to give you a pretty good benefit in terms of resiliency in the short term. If, basically if you did the whole thing, including the roadway, and I think the roadway could probably be feasible within the time frame we're talking about. But your share of that based upon this estimate is about 300,000. And it would take care of a good amount of the manholes that are subject to flooding, in the short term. Is there any limit on the grant?
I think they've had more money recently. I think they limited it to 1 or 2 million for the grant component.
Okay. So that's still some feasible interruption to them.
Right. Yeah. I think looking at, again, at the paving plans might make it, there could be like, there's like that one on Black Horse Lane, right? Okay, so you can go and replace that without having to go repave all of Black Horse Lane, but maybe there's some where you want to wait for that paving, project to minimize the disturbance and construction, et cetera. But yeah, generally, that would get you a good level of protection. I don't want to like over advocate for the access road. I think it is important from a safety perspective, from a flexibility perspective. But it's also, like I think with the when the treatment plant is on a 24-hour staffing because of storms, you know, someone may be at the pump station and then how do they get to the treatment plant from the pump station, you know, or, you know, do they have to double staff, you know, with a person at each one, you know, in case they can't traverse from one site to the next, or do they need a boat, you know? So there are some other operational strategies that you can use to live with the, you know, the impacts of losing access to a degree, but there are still residual safety, you know, things that you can't get rid of.
One of the
without
other,
doing.
one of the other things that we have to think about too is sludge removal at the plant. We do regular sludge removal,
That's a great
and
point.
a significant storm event would basically isolate the treatment plant.
Yeah.
So there may need to be like an alternate pipeline where we can remove sludge or pump sludge towards Elm Street for tank removal. So that's another concern too.
Any other thoughts from folks? And this is your chance. I think, you know, Brian would come back to you if we've got the, you know, application together, but I think he, you know, he would like to do this, and I think it would be important for him to know whether he has support. I'm speaking for Brian. Brian can advocate.
Well,
for
I
it.
mean, some of these things we have to do, it's just a little overwhelming, you know, at the moment, but,
Yeah.
Wow.
Okay. All right, well, let's blow your mind some more. As we look out to 2050, a lot of these same strategies were presented to you previously. I did modify some of the costs just based on the lower flood elevation, but most of them stayed somewhat the same because you still need, like, for example, when you install a flood door, that flood door has baked into it 3 feet of flood protection. So even if you only need 1 foot of flood protection versus 2 or 3, you know, buying the flood door gets you that. So the flood door doesn't cost any less, unfortunately. So I also, I think, reorganized this a little bit. I think it was a little bit confusing last time to kind of be able to disaggregate, like, you know, someone said, oh, so we have to do this perimeter flood wall and we have to do XYZ. So I tried to make it a little bit more clear here. When in option 4, for example, if you have this site-wide perimeter flood wall, then you don't need to do any individual adaptations to the blower control building, treatment facility, emergency generator, et cetera. Those would be protected by that flood wall. Similarly, if you were to, in option 3, build the facility perimeter flood wall just around the treatment plant with the gate, then you wouldn't need to adapt the blower building, that it would be already protected as part of that. But you would still have to raise the generator and, you know, dry flood proof the influent pump station, which are, you know, which would not be protected by that. So the options here range from, you know, like 1.5 million or so to 4.5 million. You know, depending on how many manholes you decide to replace. And again, this can be just kind of, it can become as it sort of is already part of ongoing kind of roadway maintenance, you know, in a way, to do these replacements as you replace roadways, as you rehabilitate roadways. A chunk of the cost in all these cases is still that access road. So if that's been done prior to the 2050s, you know, if that's done, you know, with that target 2030 set of strategies, then that drops out of these costs and the costs become a lot more manageable.
Yeah.
So the cost to, you know, protect individual assets is not so high. I don't love the options for protecting the treatment facility that are not like the dry flood proofing options for the treatment facility, just because of the way the building is designed. I don't like any of them really. I really just like the perimeter protection strategies, you know. I think once you're into this time horizon anyways, the probability of flooding of the site is so high that, you know, you don't want water in your building every day or every year. Because that over time will really degrade,
Mhm.
existing corrosion problems in there from, lack of ventilation will become, corrosion problems from salt exposure.
I would agree too with the perimeter flood wall. That's a better strategy overall.
Yeah.
Protects the site a lot more. And there's a possibility where you could basically just extend the existing wall and add some reinforcing. So the cost might be able to come down a little bit.
Yeah. So yeah, it's, we're as part of the scope of this project is to kind of provide you with these options so you can think about this and have, these costs in mind as you consider, there may be things between now and 2050 that you do a bunch of equipment replacements because, things have reached their end of life. And as part of that, you raise them up a little bit to make sure that, they're in line with these future flood elevations. And then, I don't know, maybe your pumps or your compressed air systems are not vulnerable in the treatment plant anymore, or maybe the motor control cabinets in the blower building are raised higher off the floor. They're things we can't anticipate necessarily about how the infrastructure will evolve over time, but these are kind of structural solutions that could work if and when you're facing these risks.
I think the idea of regional solutions too could impact this overall too. You may get better protections with regional solutions if they implement them.
Agreed.
Obviously, that's a significant amount of money for those.
Yeah, but the benefits will be a lot higher too, because it won't be just the treatment facility that's
Exactly.
protected and these costs avoided, but also all the residential and commercial.
So a lot of this has, kind of hinges on what a regional solution would be implemented or not.
It's true.
One other thing too, a lot of these solutions or preventative measures in terms of design, permitting, and construction, these are kind of on a maximum maybe of about a 5-year period. So you do have some reaction time there. I know right now we're tracking a little bit below the intermediate, but I mean, it could go up as he had indicated before. We could be on the high side, but you do have a little bit of time frame to react to some of these and to adjust. It's not like a regional solution where they need 20, 25 years to actually implement something.
Yeah.
Most of these solutions that you have could be addressed in a 5-year period. So I'm not saying wait and look. Obviously, there's a lot of things you can do anyways that would help you, like the watertight manholes, but I think you do have some reaction time here.
Yeah, no doubt. I mean, again, as I mentioned, even in 2050, the risk of failures are, at that, aside from the electrical equipment, at that 50-year return period, which is still an extreme event with a ton of sea level rise. So yeah, relative to other communities, again, your urgency is relatively low for the more critical facilities. It's just these pernicious problems like inflow that will become more and more of a problem if you don't do something about them. So hopefully with relatively that's kind of maintenance work that needs to be done anyways. These are 50-plus-year-old, I think, manholes out there in the meadow, and it just makes sense to do that work. That's why Brian's been trying to work it in.
Yeah, I'm sorry. Some other concerns too is basically the pipe system itself. The gravity collection system, it has a limited amount of hydrostatic pressure that it can resist. So if we're talking additional flood levels or higher flood levels, that pressure is going to increase and your II problem would worsen over time. So, I mean, there's strategies like, lining pipes or replacing pipes that you may have to start looking at in the future if we're looking at higher flood elevations and higher hydrostatic pressure.
Yeah, it's definitely something you can monitor and adapt. See, are you starting to get more salt water in your incoming fluids, and how does the system react during big storms, et cetera. Anyways, I took too much of your time. I don't want to take any more. The rest of these slides are just kind of extra, graphics, and
Yep.
this is the meat of it.
It was good stuff.
Thank you for your time. I appreciate it. And
No, thank you.
if you have any questions, just let Brian know and he'll loop me in.
Yeah, thank you.
Thanks all. I appreciate your talk. Hey, Scott. Bye.
I think the Heinz are on now too.
I just put Mary Hines on the call, and she is the abatement.
Okay.
I'm just asking her to unmute. Mary?
Yes, hi.
Hi.
We don't seem to have video. We have terrible Wi-Fi here. So I apologize.
That's okay.
We're on 2 devices just so that we can try to hear everything.
If you'd like to explain to the board your abatement.
Sure. This is Mary Hines. My husband Rich is here, not that you can see either one of us. We were away in January and February and apparently had a water leak. We got a very polite phone call upon our return from the water department saying that the bill was going to be over $5,000. So, and she had people check the service and found that it abated when we came home. So we assume it was a toilet running that got used when we got home and stopped. So we obviously weren't anticipating that kind of a bill, and are usually pretty good about water usage. And after years of a pungent backyard, we were delighted to be able to sign up to sewer service from my parents years ago. But we're just asking, if there's a way to, we filed an abatement. We're asking for that to be passed so that we don't have this terrible bill to pay. I think that's mostly it.
What was it your toilet that was leaking, or?
We don't know for sure because we came back and again, we came back, used bathrooms, and then a couple of days later, Brenda from the water department called and told us what had happened, but whatever had leaked or whatever had stopped when we got home. So we don't have a way to figure that out. But we did change the flapper in one toilet, which we suspected might be the culprit. As soon as we heard about the leakage.
Well, if it went into our treatment plant, we processed it, whether it was, the right stuff or not. But in other circumstances like this, we've given like a 50% abatement. Has the water department given you an abatement?
No, they don't meet till I think next week. But Brenda suggested that we put this in. We didn't even know what the process was.
Yep. Wayne, thoughts?
I don't know what the numbers are that we're talking about in terms of.
Well, they got a $5,000 bill. I don't know what the bill for sewer would be on this one. Do you know what the bill on sewer is?
Yeah,
Yes.
we've got it here.
The bill
sorry.
is $24.80. And their average bill is $144 per quarter.
Wow.
That is the sewer portion?
I can speak with Brenda to find out what they're going to do on the water side after the meeting, if you want to wait.
No, I don't think we need to do that, but I mean,
Okay.
but as far as this period of time, the bill for sewer was $2,480.
Correct.
Okay. So the combined bill is the $5,000 number.
Correct.
And the normal is 144?
Yes, average is $144.
I'm in favor of giving a statement. I just don't, is it?
Half of the 2480 would be 1220 roughly.
1240, right?
1240, sorry.
I would make a recommendation to give an abatement for 1240.
Yeah, I would, okay, I'll make a, yeah, and I'll second that. So we're, on the table right now is to give an abatement for, $1,240.
Mhm.
We'll do a roll call vote. Bill McGowan, aye.
In Sawchuck, aye.
All right.
Mary, are you good with this?
Oh,
Yeah.
we're grateful for anything you can do. Thank you.
No, no problem.
Okay. Next,
Thank you, Mary.
Thanks.
Okay, next is Woodard and Curran's presentation and findings.
Okay,
was this the monthly? Woodward and Karn came out with this new thing for the first time that I've seen it, which was terrific. And it was for, I think, just a 1 month period. And so it said everything that the plant did, pumped out, all that stuff. So is that? what it-
You should be getting that every month. We do provide that. So I do
Yep.
think that month, that was a monthly report that we give out generally every month for the preceding months.
I just don't recall. The one I just got was the first one I've seen.
Okay, all right.
I'll make sure to follow, to send them along every month when I get them.
Today's presentation is regarding the CCTV work that was done on the system and the findings on that. We don't have a report yet, but they were going to give a presentation today.
Okay, so I'm open to anything.
yeah, so who's giving it? Rob, are you giving the presentation or Scott?
I'm gonna let them jump on. So Rob is on, Peter Lyons is on, who was with Woodard and Curran as well. And Peter will be giving the presentation. Peter, I'll let you take it away. Thank you.
So, and probably an uncomfortable question, but how long will this take? I've got an 11 o'clock call, so I can push it back a little bit, just say that I'm.
No, we
So
can.
Bill,
can
I
do this
explained,
in
I explained to Peter that time is of the essence, and he's going to give you a quick overview of the map, the summary,
Beautiful.
understanding that 11's 11.
Yeah, my other high-paying job is awaiting me, so.
Okay. Pete, it's all you, no pressure.
Okay, I'm gonna share a screen. Let's try this one. Yeah, we'll just hit high level notes here, and more follow up. Am I on the right? No, I'm on the wrong. Because this. Oh, you are seeing that. Are you seeing a map right now?
Yeah.
Yes.
Okay. So I'll just hit high level notes, and we can run through it. We'll be generally pretty fast. So we worked with Brian sort of towards the end of February through April 5th to inspect basically everything highlighted in blue here. Here's the treatment plant. And the goal of this is just to document potential infiltration sources as well as structural defects. So yeah, everything in blue was inspected. We attempted to inspect these pipes, but we didn't have access. And then these pipes we held off of because we were causing some backups when we inspected this side. So we just felt like we wanted to be conservative and not put backups there. So these pipes in green were inspected probably 2 or 3 years ago prior to a road paving project. So high level notes, we inspected 65 pipes. That's about 10,000 feet. it flows at the plant. This was coming up because flows at the plant had been high. We'd waited for them to come down so that we could see the pipes in better detail. Basically, all of the pipes we inspected showed varying levels of infiltration. So varying between like staining on the pipe from mineral deposits to active infiltration. 17 of the pipes had a pore.
Peter?
Yeah, I think he's frozen.
Yeah, it looks like it.
It might be like an internet thing with him.
Yeah,
Scott,
yeah, he just dropped off.
Scott dropped up there.
No, Peter Lyons just dropped off.
Oh,
Hope he drops back in.
Yeah, I'm waiting.
He just texted me to say he's going to rejoin. He got kicked out.
Okay.
huh.
In this brief lull here, I just wanted to say that I'd like to have Dan meet with the contractor and give us a price on the Atlantic Avenue project where the bridge was. So I wanted to make a motion that we could allow him to come down and work with the contractors to see what they come up for an estimate of the cost. Is that all right with you, Bill?
Yeah, it is. Dan, if you can give us a price to do that, please, prior, but I would make a motion that we look at putting a pipe, making that connection at the bridge.
I second that.
All
At
right,
which bridge?
Cunningham.
Okay.
And sorry, and so we'll do a roll call vote. Bill McGowan, aye.
Inside check eye. Thank you.
Yep.
All right. It doesn't look like he's coming back on.
Something's wrong. Something's wrong with the internet, I guess.
Mm,
So Peter is on the cell phone with me. He's trying to get in. He thinks he lost his internet.
Oh, it's gotta be the Russians.
Do you have the presentation, Rob? Maybe you could put it up.
Say that again. Hold on a sec, Dan. One moment, please. Say it again, Pete. Okay. Oh, through my phone, you mean? Okay. That's what we'll do. I do not have the presentation, Dan, everybody. Peter can send it out as an email after. He has no internet at all.
Oh,
Yeah, that's fine. And then we can pick up on it on
Next meeting.
7th.
And then you'll have it. Yeah, everyone will have a chance to look at it, read the findings. He's got it summarized on the sheet.
Yeah, and Rob, perhaps we can even reschedule to the next session.
Perhaps what, sorry?
We could reschedule to the next session.
Yeah, I
June
think
7th.
that'll be better instead of trying to rush through it.
Okay,
If you don't mind, we'll just preempt this. Peter will send it out we'll send it to Carol for
Yes.
distribution to everyone. Is that okay?
Yeah,
yes.
that'd be fine.
Okay, thanks, guys. Sorry about that.
No problem. No.
There was something else, I think, on the outage, or no? That occurred. Is that all satisfactorily?
Well, most of the information that I have for that is coming from Brian, and since he's not here,
Okay, then let's postpone.
Yeah, we know that something occurred, blockage occurred
yep,
and, I know that Scott was part of the mitigation on this and as well as Woodard and Curran, excuse me, as well as FR Mahoney and Rosano Davis. As far as I know, everything is working well, but unfortunate. Scott, do you want to say something or?
Yeah, I can just give you my part of, what happened and where we are currently with it. Obviously Saturday afternoon, there was a blockage somewhere where we, everybody was calling in on overpressures. So I was able to go out there, kind of assess what was going on. We were able to open the valve back up to Hull to relieve the pressure. And that allowed all the flow to, obviously go that way to Hull. So now we could tell approximately where there is some type of a blockage. But we're working with Brian and Rosano Davis. But as far as my understanding with the homeowner, Brian called up Wednesday. We went out there. We opened up her tank and her pump was running but wasn't discharging. So we just, as we always do, we just advised her to call FR Mahoney. And that was kind of the last I've heard about it until just the other day. I didn't know that there was, some extensive work that had to go on there. But she is up and running from my understanding. She's
Yes.
up and running since that day, since Rosano Davis fixed everything. So, I think she's just upset about the money factor and wants to know about that. That's
Well-
my understanding of the situation.
she's upset because she doesn't think we're taking this seriously enough. That was what she told me over the phone. She said she doesn't understand why this isn't a bigger deal than it is.
Scott, are these 2-inch pipes that are potentially in one of the blockages or have, is it? In other words, what size pipe are we dealing with that backed up?
So it is the low pressure. We don't know exactly where it is. And that, to me, unfortunately, that's a very not labeled very well part of town due to how it got, from my understanding, how it got hooked up in different sections. So I need to sit with Brian and maybe even Dan to kind of figure out exactly what is going on over there. But I don't know, Wayne, to answer your question, I don't know exactly what size pipe is there. I imagine when Brian comes back, I think he's back tonight. I think we'll be sitting down tomorrow to come up with a plan for this.
And did anybody see any construction activity around, in the area where that development is? In other words, was anybody, digging in the ground that might have, caused,
So there's no real construction going on right there. We're talking the area of Forest Ave to Linden Drive.
oh, okay.
The only real construction going on is the Forest Ave extension. But we don't really have sewer. I mean, we have sewer over there. They work, it's actually in Hull. It's just the other side of Forest Ave before it goes into Hull. That's the only active construction going on that I'm aware of.
Or did you check all the valves? Scott?
we walked the street just to, that was the plan, was to check all the valves, make sure they were all open. But while walking the street, there was really no need to open up every cover, because you could tell right away whether someone was in the cover or not. Because they're all covered over with dirt and schmutz. That every one of them, you could tell no one's been in it, because that was my first thought. Maybe something got closed. But I personally walked the street from Howe all the way to 492 Jerusalem. And not one valve in the road appears to have been played with.
Yeah, the last time we had a blockage like that, we had, I think the water department might have gotten on one of our valves. And instead of opening it fully, they opened it halfway, which is a practice by the water department.
Yeah.
And opening it halfway doesn't work with wastewater solids, so.
Now, there was no
it can take
evidence
a-
at all somebody was in any valve.
Yeah, well, sometimes it can take a while. That's the thing. When it's half full, the flow still goes for a while until it can't. So it still might be worthwhile trying to get on those valves and making sure they're fully open.
It wouldn't hurt to exercise the valve anyway, right?
Right.
The only harm, Wayne, would be finding or breaking valves, or finding valves that are frozen at this point. And I'm not trying to get out of exercising valves, but there is that concern that these valves have been
Right,
sitting.
I understand, because, we've had a process of at least once a year going in and exercising the valve. But maybe we don't do that anymore, or maybe that wasn't done in, one place. But if we can't shut off a valve or open a valve, what's the reason for us to have the valve there? There was a reason, and the reason was to be able to isolate things. So if we find one we can't break, I'm in favor of digging down and replacing the valve. Or whatever or making it so that it's most of the time could be dirt or anything else in it, or a stone going in it, and you don't have to bake. It's getting the thing that's causing it that may be outside the valve to make the valve work right. Anyway.
Yeah, no, I agree with you 100%, Wayne. That absolutely.
Okay, so let's just table this. Let's just, see if we can try to find. And obviously, it could be one thing that went through that shouldn't have been thrown down the toilet or the sink or whatever.
Yeah,
And the other thing, the other possibility is that reversing the flow could have freed up any type of blockage. And now when we turn it back, we may or may not know exactly where it was.
Yeah. Flow reversal has positive and negative aspects too.
Absolutely.
Yeah, I mean, because you can have a blockage create itself behind a valve that's been closed.
Yeah.
Right.
So,
Okay. All right. Anything else? I think we've got 11 o'clock and we've got to get off the call.
yeah. I think we're good. Anyone else have anything? No? I'll make a motion to adjourn.
Second,
We'll do a roll call. Bill McGowan, aye.
Wayne Sawchuck, aye. Thank you.
Thank you, everybody.
Thank you.
You.
All right, take care.
thank you. I know.